we talked about radian measure and how we can convert radians to degrees or degrees to radians, right? So that's really all that you've missed. Not missed. That's all that we sort of did prior to break, right? So now we're on probably the most important lesson, guys, of this entire unit. It's really going to take us 2 days to do what I need to do to tell a whole story, okay? Because the story is going to sound kind of incomplete today. All right, so you're going to be left wanting more, Trinity. You're going to be like, man, I really got to know the ending to that story. So you're not going to get the ending until tomorrow, okay? But we're going to start building the story today. Those of you that took Geo last year should be able to at least narrow down example 13 to 2 choices. What I want to do, guys, is I want to find the equation of a circle that would represent the equation of a unit circle. Now, guys, the definition of a unit circle is one that is located at the origin with a radius equal to 1. So, I said if you took geometry last year, you should at least be able to get rid of 2 choices. Which 2 choices are not equations of circles at all? Well, choice 1, x plus y equals 1. If I asked you guys to graph x plus y equals 1, what would that create? A straight line. So this is the equation of a line. So it's not that. Choice 3, y equals x squared plus 1 is a graph of a what? A parabola. So it's not choice 3. So here's how I know it's either choice 2 or 4. What do you notice about both x and y in choice 4 and choice 2? They're both being squared. So a circle always has an x squared and a y squared. Okay? Now, again, if you didn't take geometry last year, you don't know what I'm talking about right now. So don't really worry about it because that's not the lesson. Okay? And if you notice right here, guys, what am I adding or subtracting to x? Y squared. Am I adding or subtracting anything to this x individually, though? No. Anything to this y individually? No. So that means that this is centered at 0, 0. And so this is our choice. X squared equals y squared equals 1. That's called the unit circle. It's a circle centered at the origin with a radius of 1. All right, hold that thought. We're going to use that thought in a minute, okay? Because I'm not doing anything to the x. I'm not doing anything to the y. See what I'm doing over here? So this is not centered at 0, 0 because I'm subtracting or adding. Okay? And quite honestly, as long as you didn't, it's not really a part of what we're going to do right now. So don't worry too much about that. Okay. Guys, what I have here is a special triangle. It's a really, really special triangle. It's a 45, 45, 90 triangle. Those of you that took geometry last year, tell me what I know about this triangle. There are a couple of things I know. It's a special one. What's special about it? It's a right triangle. Okay, so it's a right triangle. What else? Those of you that took geometry. Yeah. Well, so hence the right angle. Hence it's a right triangle. So yes. There's one other thing that's really important about this triangle. What's kind of, say again? There's 2 45s. Agreed. That's kind of where I'm going. Which means it's what kind of a triangle? Isosceles triangle. And what do I know about an isosceles triangle? And even if you didn't take geometry last year, that word should sound familiar, shouldn't it? An isosceles triangle is a triangle that has 2 sides that are what? Equal, right? And in this case, what 2 sides are equal? The sides that are labeled with the x's, right? And then I have 2 angles that are also equal, right? So this is an isosceles right triangle. Now, I created this triangle by doing this. Don't draw this, Hazi. Don't draw this. I took a square. Okay, don't draw this. And I said, this is the most general square I can draw. What's general mean? It means I didn't put anything specific on it. I know a square has to have right angles, correct? And I know that it has to have sides that are all the same. So did I draw them all the same? Well, yeah, I call them all what? X, which means they're all the same, right? So what I'm going to do now is I'm going to take a knife and I'm going to cut it right in half. Well, when I cut it right in half, I get rid of this. Let's pretend like that's not there. Well, what did I do to this triangle? I cut these angles in half as well, didn't I? Which created the 45 and the 45. So do we see where that picture was born? Okay, good. What's up, Steve? All right. So next thing I want to do, I want to actually figure out what the value of X is in this picture. Well, you guys said it was a right triangle. If it's a right triangle, what can I use to find the length of a side? I can use the Pythagorean theorem, can't I? Which of those has to be the letter C? The X, or the 1? Why is it the 1? Because the C always has to be the hypotenuse, right? It's always got to be the longest side. So I have x squared plus x squared equals 1 squared. So what did I do, guys? I took these two things and plugged them in, and I set it equal to the hypotenuse squared, right? What's x squared plus x squared? 2x squared. Absolutely it is. All right, how do I solve this? Give me something to do. Divide by 2. To combine them? Yeah, they do. All right, hang on, I don't get it. Say again?
Like you put x squared plus x squared.
Yeah.
But I thought,
This and this.
yeah, so when it only goes to give 1 x squared.
Okay, so here I have an x squared. So how many x squareds do I have here? 1. How many x squareds do I have here? So how many x squareds do I have in all? Right? It'd be like saying, what's x plus x?
Oh.
Same idea, right? As long as they have the same exponent, I can combine them, right? All right, so I get x squared equals a half, right? How do I get rid of the square? Square root, of course. And I get the square root of a half. We don't like that, do we? We don't like fractions, right? Do you guys agree that that's the same as this? What'd I do? I just put the radical on both, right? What's the square root of 1? Okay, so now it's that, right? And what do I not like still? I still don't like something. I still don't like the radical in the bottom. And we spent a whole unit talking about, not a whole unit, but part of the unit talking about how to rationalize this. If I don't want the radical 2 in the bottom, how do I get rid of it? Say again? Okay, so you're in the right unit. You're in the right unit. You got the wrong technique. You're in the right unit, though. I got a radical 2 on the bottom. How do I get rid of it? We're getting there. We're getting there. What's radical 2 times radical 2? Radical 4, which is 2, right? So what the technique that we actually used, guys, was if I multiply the bottom by radical 2, what do I also need to do? Multiply the top by radical 2. Because, guys, if I multiply the top and the bottom by radical 2, what's anything divided by itself? 1, right? What's anything divided by itself? 1, right? So if I multiply by 1, did I change the value? No. What's 1 times radical 2? Radical 2. And you guys just told me that radical 2 times radical 2 is radical 4, and radical 4 is 2. All right, so the value of x is radical 2 over 2. Correct. That's exactly right. Guys, if that sounds familiar, hey, I'm going to do a quick 10-second Regents review. Ready? If I gave you this, and I said rationalize it, we don't like it because of the radical in the bottom, right? But there's two things underneath. So in order to rationalize this, we have to multiply by the what? What's that called? By the conjugate. By the conjugate. All I did was change the sign in the middle. Yep. Yep. All right. Again, guys, the reason that I'm doing this right now should seem very, 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 very unclear, right? Why are we all of a sudden talking about sides of triangles? Well, okay, let me answer that question really quickly. Guys, what's this whole unit called? Trigonomic functions, right? And what was the first lesson that we had? What did it deal with? Reference angles. And the second unit we had dealt with degrees and radians. What do we need degrees for? To measure angles. And where do most angles show up in math? In shapes. More specifically, triangles. Now, we're going to put triangles on a circle. That's where we're going. So you're right. Okay, this is another special triangle. Okay, and again, the reason what we're doing right now should not make any sense. It should be like, what are we doing this for? Don't worry about it. Okay, we're going to get there. Here I have a picture. Hazy, don't write this down. Hazy, what I just did is I took this picture and I drew it over here. And then what I did is I reflected it and I created the same picture on this side, okay? So that means that this angle right here has to be what? 30. And this angle right here has to be what? 60. And this one has to be a right angle. And if this is 1, this side has to be 1. Okay, now check this out, guys. These two angles put together makes it what? 60, right? So if I was to get rid of this, this would now be what? Oh, geez, Picardo, what are you doing? If I was to get rid of this, these would now be a 60-degree angle, right? So what kind of triangle would this be? Equilateral, right? Which means all the angles are the same and all the sides are the same. So this whole side would be of length 1. But Hazy, I said that I duplicated this picture, right? So if this whole bottom is 1, what does this have to be if I didn't duplicate it? It's not 1, it's a half. So where did this picture come from? I took an equilateral triangle and I split it down the middle, right? You guys see it? Okay. So how many sides do I know? 2 sides. What side do I not know? That third side. How am I going to get it? All the same way that we did it a minute ago, right? Which of these, I'll call this an X. Which of these has to be the C? The 1, the X, or the 1/2? The 1. It always has to be the what? The hypotenuse, right? It's always going to be the longest side. So this is going to be a half squared plus X squared equals 1 squared. What's a half times a half? Please be careful. Okay, that's 1/2 plus 1/2. 1/2 times 1/2 is a fourth. Subtract a fourth. That gives me 3/4, right? Square root. Radical 3/4. which I can now make radical 3 over radical 4. This is the nice one because what's the square root of 4? So the missing side is radical 3 over 2. I put that in the wrong spot. Sorry. I should have put that in the part below. Guys, what I need you to do down here, I need you to draw the following and then circle it, star it, and highlight it. You have two right triangles that are important to remember. You have a 45, 45, 90, in which case the sides are radical 2 over 2, radical 2 over 2, and 1. And then you have a 30, 60, 90 triangle, where the sides are 1/2, 1, and radical 3 over 2. And I said take these two pictures and circle them and star them. From the previous problem that we did? From two previous problems that we did. Got it? Guys, ready? You have to be able to answer this question. Blake, how long is the side across from 30? 1/2. Jaden, how long is the side across from 45? Radical 2 over 2. Does it matter which one I go across from? I'm going to get the same answer both ways, right? Caesar, how long is the side across from 60? Radical 3 over 2. In both of these pictures, how long is the side across from 90? 1, right? So you need to be able to answer what's across from, okay? What's the hypotenuse in both of these pictures? 1, right? Okay, so this is all real important. You're going to have to know these pictures by heart. You're going to see why right now, okay? This picture, if it looks confusing, it's because it is, okay? So what I'm going to do is make it a lot easier for you guys by focusing your attention only here. All I want you to do is look at this quadrant. Which quadrant is that, by the way? That's the first quadrant, right? Quadrant number 1. Okay? And what I want you to know is the following. Ready? Here, do you see how I have some overlapping triangles? Okay? This is going to be a reference angle. What's that reference angle listed at right now? 30 degrees. So if I was to label this, that would be a 30-degree angle. Everybody cool with that? Now, do you see how this point is on the circle in the picture? Right? Everybody sees how this point's on the circle, right? Notice something about this circle. What is the center of this circle? 0, 0. What's this point? 1, 0. What's this point? 0, 1. What's this point down here? 0, -1. So what's the radius of this circle? 1, right? Because what did I do? I went right 1, I went down 1, I went up 1, I went left 1. So how far is it, everybody, from here to here? 1, because that's the length of a radius, isn't it? All right, so this distance right here is 1. Now, notice what happened, and this is where it's going to get real important, okay? Do you see how from this point right here, I drop straight down to that safety axis? Well, if I dropped straight down to it, give me a phrase. What was I to the axis? Perpendicular. And what does a perpendicular angle create? A right angle. So that's a right angle. Do you guys see how by doing that, I create a right triangle right here? Okay, so here is a right triangle now. Now, this is why I asked you guys, that I said you guys need to be able to answer this. Ready? Do you guys agree that if this is 30 and this is 90, what do the angles of a triangle have to add up to be? 180. So if this is 30 and this is 90, if I subtract those from 180, that means this has to be 60. Now, doesn't that create that special right triangle that we made a few minutes ago? How long is the side across from 30? Yeah, look back and tell me what it says. 1/2. And how long is that side across from 60? Look back. Radical 3/2. Okay. Now, if I asked you guys to label this point up here, if I asked you to label that point right there, I've given you lengths of things, haven't I? So to get to this point, what do I need to do? From the origin, I need to move left or right. Need to move to the right. How far do I have to go? Radical 3/2. Then I have to go up. How far do I have to go up? 1/2. Now, if I go to the right and I go up, don't you agree that moving to the right means that my x value is positive? And going up means that my y value is positive. So is it fair to say that I could label this point as radical 3/2, comma, 1/2? Is that cool? All right, now I want to focus your attention to quadrant number 2. And I'm going to draw a different triangle over here. I'm going to make this my angle of interest. What's my angle of interest? 135. Okay, ready? I'm going to bring you to lesson number 1. If 135 is my angle of interest, what is the measurement of my reference angle? Do I want to go back to 0 or do I want to go forward to 180? Forward to 180. So what is the measure of the reference angle if I got to go from 135 to 180? 45 degrees. Now, ready? From this point, which is on my angle of interest, I'm going to drop straight down so that I am what? Perpendicular to the x-axis. So if this is 45 and this is 90, what does this angle up here have to be? 45. In this red triangle, do any of these sides represent the radius of this circle? Yeah, this one right here, right? Because it goes from what? The center to the point on the circle, right? So this is 1. In a 45, 45, 90, everybody, what is the length of the two sides across from the 45? Radical 2/2. Can I label this point up here now? Okay, how do I get there? Starting from the origin, do I move left or right? I move left. How far do I move? Radical 2/2. But since I move to the left, it's negative. Then I have to go up. How far do I have to go up? Radical 2 over 2. Going up means that it had to be what? Positive. And that point is labeled as negative radical 2 over 2 and positive radical 2 over 2. Again, the purpose for why I'm doing this should not be clear. It's just a skill that we need to be able to do right now, okay? Let's do one more. Let's put an angle of 240 degrees. Angle of interest. If I asked you guys to reference that, would I go back to 180 or would I go forward to 360? Back to 180 because that's the shortest way, right? How far is it to go from 240 back to 180? 60 degrees. So now to draw my triangle, I go to that point on the unit circle and I drop, or in this case, I go up to the what? To the x-axis to create that right triangle. That's not even close to drawn correctly. Let me try it again. Better. Boom. There's a missing angle in this triangle, isn't there? How long is it? Or what's the size of it? There's a missing angle, 30 degrees. Now go ahead. What's the length of the radius? Well, the radius, is this the radius? No. Is this the radius? It is? A radius starts where? At the, or in this case, in the origin, and goes to a point on the circle. So this is my what? This is my 1, right? Across from my 30 is 1/2. Across from my 60 is radical 3 over 2. So if I asked you to label this point at 240, how do we get there? From the origin, I move to the left. So that makes the half what? And then I move down how much? And it has to be negative. Do you guys agree that I could do that for any multiple of 30, 60, or 45? Yeah, any one of them, right? Any one of them. Okay? Guys, what we just did is we created triangles on the unit circle. Is that a difficult process if you know those basic triangles? Yeah, as long as you can create a reference angle, you should be good, right? All right, so down here, all right, negative 120. What I want to do is I want to put this on my unit circle, and I want to figure out that point. Okay, I want to figure out that special point. So this is going to take into account two things: what we did the first class, and then what we did today, right? Negative 120 means I need to rotate clockwise or counter? Clockwise, that's exactly right. So this is 0, negative 90, negative 180. So does everybody agree that negative 120 puts me right here? Is that cool? Now, if I asked you guys to draw your circle in, we're going to draw our unit circle in. What am I drawing? A circle with a radius of? With a radius of 1. Good. So do I, right now, I know what my radius is, right? This is my radius right here, correct? What's my reference angle? I'm at negative 120. Where do I want to go? Back to the 0 or to the negative 180? Which is the shorter way? To the negative 180. How far away is it? 60 degrees. So that is 60. And then what am I going to do? I'm going to drop straight to create my 90, which means that the missing angle has to be 30. 30 comes from the fact that if I have a 90-degree angle and a 60-degree angle, the other angle has to be 30 to add up to 180, right? Let me try to, this is a mess. Let me redraw this. This is terrible. I'm disappointed. I could probably actually just do this, right? Oh my God. That's a little better. There's that. There's the point. Straight down. Boom. You guys said this was 60. You guys said this was 30. This was my radius, right? Okay, so I have everything labeled, right? Except for the two missing sides. So when you ask yourself, what are some things that I can study for math? This is one of them. What is the side across from the 30 equal to? A half. What is the side across from the 60 equal to? Radical 3/2, right? Blake, can you answer that for me? Huh? Did somebody call it? No. So how do I get to this point? From the origin, I move to the left. How much? A half, which means it's what? -1/2. And then I move down, which means it's negative radical 3/2. $495. What do we not like about 495? It's bigger than 360, right? So remember, if I wanted to answer this question, what might I do? Find a coterminal angle, right? That's what you're describing. I'm going to subtract 360, which gives me 135, right? So 135 is coterminal, which means in the same position, right? Go ahead and draw a reference angle at 135. All right, so I got my unit circle. Where'd you guys put 135? Hopefully you put it right here. What did we get for a reference angle? Oh, I'll wait. 45. Why 45? How'd you get it? 180 minus 135, right? Yeah, this has got to be my reference angle. Okay, what am I going to do now? I want to label this point right here. What am I going to do now? Bring it down, drop it down. That's got to be my right angle then, right? What's the other angle that I didn't write down? It's also got to be 45, right? Do I have a radius? This is 1. What are the other two sides? Radical 2/2. So if I want to label this point up here, how am I going to get there? I'm going to go to the left, which means negative. I'm going to go up, which means positive. Okay. Guys, these next two examples is going to be a review of everything that we've done so far in this unit. Pi over 3. Why would that be difficult to analyze? Because this is in terms of radians, right? How do I convert radians to degrees? What does pi equal? 180, right? So this is the same as 180 degrees divided by 3, or 60 degrees. So I got to play this little game with 60 degrees. I'm terrible at drawing circles. Actually, this one's pretty good. Except for that side. That side's bad. That was pretty good, right? Thank you. So 60 degrees, guys. This is 60 degrees. What's the reference angle? 60 degrees, right? Drop it down. There's my right angle. What's the measurement of my missing angle then, guys? Gotta be 30, right? Can I label a hypotenuse? Yeah, it's 1, right? So across from the 30, my 30's right. My 30's right here. What's across from 30? 1/2. Which means this has to be radical 3 over 2. How do I get to this point? From the origin, I move to the right and I move up. So that means they are both positive. So the point is 1/2, comma, radical 3 over 2. This is a really, really interesting one. Okay, this is a special case. And believe it or not, you're going to want as many of these as you can get because this is actually the easiest thing we can do. 3 pi over 2 is in terms of what? Radians. What is 3 times 180 divided by 2? Well, how many times is 2 going to 180? 90 times. What's 90 times 3? 270 degrees. Okay. Now, 270, 0, 90, 180, 270. This is weird. This is weird because I told you guys that when we do these problems, your reference angles will always be easy to figure out because you got to get there as quickly as you can, right? 270 puts me here. So the question that you're going to have is, well, do I have to go left or do I have to go right? And I want you guys to simply remember what we're trying to accomplish. All we're trying to accomplish is to figure out the point that this goes through. Well, hang on a minute. Guys, what is this point? No, that's the angle. What's the value of this point? Ozzy? You're thinking along the right. You're thinking along the right lines. You're getting closer. 0, -1. Isn't this the point 0, -1? On a coordinate plane, right? Because remember, guys, this is a circle with a radius of 1. So didn't I simply just go down? How far? A radius. That's it, right? So if I said, guys, what is the point at 180 degrees? 180 degrees would put you where? It would put you over here, right? On the unit circle, what is the value of this point? -1, 0, right? So you should hope for those problems because you don't have to do anything, do you? Okay? Don't put anything away. We're not done. We're not done. We're not done. No, we're not done. Not done. I just want to get this first little bit here put together for you guys, okay? Because this is going to lead us into our lesson. Guys, the problem or the thing that you should be answering or asking yourself right now is, Picardo, why? Why am I all of a sudden building these triangles and finding points? Why am I finding points? Well, for those of you that took geometry last year, there should be a phrase that you remember. And the phrase that you remember was so, ka, toa. Now, right now, that doesn't mean anything to those of you that did not take geometry last year. That should sound familiar to you if you did take geometry. Now, before we actually talk about what the phrase SOHCAHTOA means, let's talk about vocabulary for a minute. What kind of a triangle did I just create? A right triangle. Because I've created a right triangle, can everybody put a big H where the hypotenuse is? You better. Big H. Now, let's pretend that this is the angle that I want to have a conversation about. Okay? What I want you to do next, we've already got the H labeled, right? What I want you to do next is, do you see how this creates one side of that angle? Do you agree that this creates the other side of the angle? Okay, what's the word adjacent mean? What does the word adjacent mean? Next to. Yeah, next to, right? Your next door neighbor lives adjacent to you. So do you guys agree that this side would be adjacent to this angle? Put an A. Okay. If I asked you guys who lives opposite your house, you're going to go across the street, right? So if this is your theta, the person who lives opposite you goes across the street. So I have an A, an O, and an H. Everybody got that so far? Okay. Here's what you need to now remember, okay? That the sine of any angle. So if I asked you guys, class, I want to know what is the measurement of the sine of this angle. You're going to remember this phrase. So, sine of that angle is equal to the opposite side divided by the hypotenuse. Check it out. SOH. The cosine of that angle is equal to the adjacent side over the hypotenuse. We're not going to do tangent yet, but the tangent of that angle would be equal to the opposite side over the adjacent. Okay. Again, I told you guys, this is the most important lesson of this entire unit, right? I'm giving you guys a lot of information, a lot of vocabulary, a lot of things that you kind of got to remember so far, right? So, here's what I want to do. Does everybody agree that here I have a picture with a theta in it? Can everybody tell me the x, the y, or the 1? The x, the y, or the 1, which one of those is the hypotenuse of this triangle? The 1. Okay, so this is the H. If this is the theta, the next door neighbor would be what? The x. So that's the A. And the person who lives across the street is the what? Is the O. All right, everybody have that? Beautiful. So, I now want to know what is the measurement of sine theta. Well, you guys wrote down that sine is equal to O over H, right? So in this picture, what side is the O? The Y. And what is the H? A 1. What's Y divided by 1? Just Y. So sine of theta equals Y. Okay, what if I wanted to do cosine? Cosine of theta equals A over H. In this case, what's the A? What's the H? 1. So cosine of theta equals X. Guys, star those two things. Got to memorize those. Got to know those. Want me to give you an easy way to memorize them? What comes first in the alphabet, X or Y? X. What comes first in the alphabet, cosine or sine? So cosine goes with X because they both come first. Sine goes with Y. Okay? Yeah, we're done, but I want to show you one more thing really quickly. Go ahead, you can put your stuff away. But I want to leave you with a teaser. Okay? Here's the teaser. The teaser is this. I want everybody in the room to be able to answer this question. What is the measurement of this? What is this equal to? Okay? So, here's the process that you would go through. Can we all agree that I can get 330 on my reference angle unit circle? Okay? Where am I going to go? I got 0, I got 90, I got 180, I got 270, I got 360, right? So can everybody be on board with the fact that this would be 330? Yes? Cool. Is there a reference angle here? What is the reference angle for 330 degrees? 30 degrees. Okay, now here's my unit circle. I'm just going to put my unit circle right on top of this whole picture. Unit circle. I want to know what this point is right here. So what am I going to do? I'm going to bring it up and bring it down, which means that this is a 90-degree angle now, right? Can we all agree that the hypotenuse is this piece right here? How long is that? 1. How long is the side across from 30? A half. How long is the remaining side across from the 60? Radical 3 over 2. Now, if I asked you guys, Blake, can you tell me what this point is? Well, I start here and I go which way? Left or right? I go to the right. How far do I go? Radical 3 over 2, right? And then I go down. How far do I go down? How far do I go down? 1/2. So does everybody agree that this point is radical 3 over 2? Is the half positive or negative? Why is it negative? Because I went down. Okay, ready? Here's where it all comes together. Does sine come before or after cosine? After. So does sine go with the x or the y? The y. What's the y value here? Negative 1/2. So I think that sine of 330 degrees is equal to negative 1/2. Negative 0.5. Okay. Now, right now, your question should, for me, should be, well, if I could just do it on the calculator, why don't I just do that? Agreed? Okay? We're going to answer that question tomorrow. Okay? We're going to answer that question tomorrow. So does everybody see where we're going with this now? Okay? So I'm going to ask you to find the measurement of trig functions of certain angles, right? That's where we're going.